All right, number 3, given a linked list, write a function to reverse every k nodes where k is an input to the function. So we have our linked list, and if we have k of 3 for every 3 nodes, we're just going to take this and reverse it. So we would have 3, 2, and 1. And then we just go ahead and we do that for every group of 3. So we will go here and reverse this. So then we would get 6, 5, 4. And then we're just left with 2. We don't have 3, so we'll just reverse the last 2. So this is what we're looking for. Okay, so here's the code for the solution, and the logic for this algorithm is we're going to be using a recursive function, and we'll be having 3 pointers, previous, next, and current, and we're going to be using these to reverse the direction that the linked list is going in groups of k, and for each subsequent remaining nodes in the linked list, we're going to be calling a recursive function to be repeating the process until we've gone down the length of the linked list. All right, so we pass through the head, and we have a k of 3, and we'll have our head, and then we'll initialize a previous node going to null. And then we'll also have next pointing at null. And current will be at head. And then we'll have a count of 0. And so while count is less than k and current is not null, we'll be going through this logic here. And so next will equal to current.next. So we'll have that pointing here at 2. And then current.next will equal previous. So right now we have current.next is pointing at 2, so we'll break that, and then we'll have it pointing to previous, which is null. And then previous will be equal to current, so we'll move this down. And then current will be equal to next. And then we will increase the count by 1. And so count is still less than k, so we'll do that again. So next equals current.next. Current.next equals previous, so we break this, and we have 2 pointing to 1 at previous, and then previous equals current, and then current equals next, and then count increases by 1. So now count is 2. 2 is still less than 3, and current isn't equal to null, so we do this again. Next equals current.next. So we move this down here. Current.next equals previous. So we break this link, and now we have 3 pointing to 2. And then current equals next, or previous equals current. And then current equals next. And then we increase count to 3. All right, so now count equals 3. Count is no longer less than k. So we check if next is not null, and which it isn't. All right, so next isn't null, so now we come down to here, and so we'll have our head.next will be equal to, and then we'll be calling this function again. And then we'll be passing next, so we have next at 4 is going to become our new head when we call this again. And then our k is still equal to 3. And so the linked list that we have now is, we have 3 pointing to 2, pointing to 1, and then that goes to null. And we have our head is at 1. So when we call this, we're going to have a head.next, which is here. So we'll be inserting what we get will be head.next here. And so if we have, so now 4 will be our new head. And then node will be, I'll just rewrite this. All right, so now again we have head at 4, and then we'll have null that both previous and next is pointing to, and then current is at our head, and we have a count of 0. And so now next equals current.next. Current.next is previous, so we break this and we point it to that. And then previous equals current. And then current equals next. And we increase the count. And then now next is current.next. Current.next is previous, so you break this, point it to where our previous is at. Previous equals current, and then current equals next. And then we increase the count to 2. 2 is less than 3, so we do this again. Next is current.next. Current.next is previous, so break that, we point there. Previous equals current, and then current equals next. And then we increase the count to 3. And so now count is no longer less than k, so we come down if next is not null, so we still have some nodes left, so we will call this again. And so now, from the previous, we want to insert what we have into head.next. So our linked list now will look like this. 3, 2, and then 1 is at head, and then head.next is what the function that we have here. So we have 6, 5, and then 4, and then null. And then we are left with 7 and an 8, and so we'll pass that again. And 4 is head, so head.next will be what we have when we pass this again, and then we'll be passing, we have next, it will be our new head. So we have 7, 8, null, previous and next. And 7 is our head that we're passing through. Current will be pointing to our head. And then we'll have count at 0. So next equals current dot next. Current dot next equals previous. So I break that off. Previous equals current. Current equals next. And then count increases. So then we have next will come to null. Current dot next is previous. So we have 8 pointing to 7. And then previous equals current. And current equals next. Then we increase count to 2. And so now current is at null, so we are no longer meeting the conditions of this while loop. So we come down, next is also at null, so we will return previous. And so previous is 8, and we're pointing for 8, 7, and null. And so what we finally have is 3, 2, 1, 6, 5, 4, and that was our previous head. And so head dot next, we're returning what we have left. So we have 8, 7, and then null. And so originally we had 1, 2, 3, 4, 5, 6, 7, 8, and so now we have the first 3 are reversed, and then we have the second 3 going backwards, 6, 5, 4, and then the remaining 2 got reversed, 8 and 7. And so that is the solution. The time complexity is O of n, since we only went through the length once, and then the space complexity is O of 1.